So we have, in this question, we have a comparison of Earth and another planet. So let's just draw these things. We've got our Earth like so. And let's see, we've got a G equals big G, big M over R squared. And an FG equal to big G, big M, little m over R squared. And we go to the planet with twice the radius. So now this planet is going to have twice the radius. But 1/3 the mass. When the box slides across the board, the frictional force exerted by the board is now, So we're now asking about the frictional force. The frictional force is mu Fn. And we know that the normal force is basically the weight. So FF is mu Fg. So the question is really asking what happens to the force of gravity. It's just a clever way of getting to that. So let's, if we have, since we're looking at Fg, so on Earth, and then we go to Fg on the planet. So the big G will be the same. The mass will be 1/3. The mass of the board will be the same. So little m will stay the same. And the distance, since we're assuming it's at the center of the Earth, is going to be 2r. 2r quantity squared. So we're left then with G m over 3 times m all over 4r squared. So we want to know that that's going to be the planet. So if we calculate a ratio, the force of gravity of the planet to the force of gravity on Earth, we have G big M little m over 12r squared. And for Earth, it is big G big M little m over r squared. Universal gravitational constant cancels. The m's cancel. Those m's cancel. The r squareds cancel. And on the top, this was a fraction. So we are then left with 1 over 12. So it's 1/12 as much, or 1/12 the original force. Now, this may have been a little messy because of the way I did that fraction up there. We could have, if this is easier to understand, said big G big M little m over 12r squared. And that m is over, we already took care of the 12. Force of gravity of the Earth is big G big M little m over r squared. So we could have done the multiply by the reciprocal times r squared all over big G big M little m. And so this m cancels with that m, this m with that m, r squared over r squared, and that leaves us 1/12. So 1/12 of the original force, FO over 12.